I'm Russell Messer. I'm with WellWorx. I am the well optimization and surveillance manager out of the Permian and also covering the Houston area. Okay, so let's start diving into the Max. A couple things to keep in mind. This tool is available in two different models, the 1.9 inch and the 2 3/8 model. Both are 40 foot in length. The only variance you're going to see is the body of the tool changes. We did that for a couple reasons. Number one is pressure drop. The 2 3/8 model is designed for an application over 650 barrels a day because it gives me that 1 inch dip tube that I like. Anything below 650, you're going to want to run the 1.9 inch tool, which has a 3/4 inch dip tube. The other reason for two different sizes is going to come down to your tubing anchor placement. While most people will have no problem running the tubing anchor at the seat nipple or above, you certainly do have the option to run the tubing anchor below the seat nipple and pull tension into this entire assembly. But if you are going to do so, you will want to run the 2 3/8 model. It has a higher tensile strength rating. So to begin diving into the flow path of the tool, we're going to start at the desander. Okay, so the desander, anytime I run a packer of any kind, I'm always going to want to recommend running a desander and dealing with those solids prior to getting above the packer where I can settle and stick, or even potentially making it into the pump. So let's deal with that problem ahead of time. I'm going to enter the slots of my desander. My fluid is going to be forced downward. It has nowhere else to go. Solids are going to settle in the mud joint, and then fluid is going to enter the dip tube within the desander. I'm going to enter through the ID of my packer, and now I'm inside my max gas separator, okay? For the next 40 feet, I'm going to be rising upward, okay? And this is where you're going to see difference number one on this tool. No baffles, emulsion breakers, spirals. We're giving gas the smoothest path possible to exit into casing. The goal, we want to reduce turbulence and emulsion as much as possible. We're doing that two ways. We're eliminating these baffles, we're giving a straight shot. We get to the top 5-foot section of our max, and we're going to exit these slots. And I'll tell you, these slots would be the size of garage doors if Russell had his way. But we can't compromise the strength of this tool. So we settled on these 6 slots. And the goal here is I want to not only increase the OD at this section, but I want to exit the slots as slowly as possible, aiding in that reduction of turbulence and emulsions as I crash into casing, right? So slow down as much as possible. This is our big moment of truth. All these downward fluid velocity calculations happens right here. My gas is going to take the path of least resistance, and he's going to run up casing. Fluid's going to fall, okay? And as I fall 40 feet, I'm going to encounter my next difference. Now I have this never before ran, this 1.9 inch OD tool body. What does that give me? It gives me a much larger separation area, or annulus. And we can quantify that later when we look at our downward fluid velocity at various production levels. So as I continue to drop, I'm in this 1.9 area. A lot of gas is continuing to rise up casing because remember, I'm only intaking into the pump and this tool half of every single stroke. So that entire downstroke, I have this stagnant column of fluid. The gas is just breaking out and rising up, right? So I continue downward, and now I'm going to get to the two biggest factors of the tool. The cup style packer and the shroud. The cup style packer allows us to do everything we can to eliminate the risk and the reality of stuck packers and packers that do not seat properly. With the deviations we see today, especially up high in that 2,000 foot range on these pad wells, it's very difficult to rotate tubing at all from the surface, much less 8 times for these rotational packers. And then if you're not rotating, you're putting 30 to 40 points into those shear pins to bust those. And it can be difficult to drive away from that well and understand, did those shear pins break or did they not, right? So that was a reality that we certainly faced over the years. This guy allows us to just run straight down hole When I get to my set depth, I'm done. No slips, no shear pins, no rotating, okay? When I'm ready to pull this system out of the hole, hopefully years from now, right? Again, no rotating. We're just gonna pull up on this. And the only thing holding me here is these cups. These cups are inverted. I'm gonna use the weight of my fluid level to help me press up against casing, creating that seal. We run dual cups. We invert them for that fluid gradient piece or weight of fluid. And we can even run quad cups if needed. These cups are made, they're metal, like mesh backed, okay? They have a lot of strength to them. You have to stab these into the hole. And you just do not want to exceed 60 feet per minute when you're running this tool, because we want to avoid any excessive abrasion to these cups. These cups are made of an HSN, high strength, high tensile strength rubber, and these guys are ran in all sorts of applications: gas lift, onshore, offshore, high pressure, low pressure, ESP desander applications. A lot of times we're getting single cups. So this is not reinventing the wheel. This guy just never made it into the rod pump piece of our industry, and we want to give it a good introduction. So I'm not going to say eliminated, but we have drastically reduced that fear or reality of these stuck or leaky packers, okay? So that's big. That's a big accomplishment, but you still have that fear of, okay, I ran it in too fast. I did damage those cups. I ran a different packer. I didn't set properly. In all these other packer style separators, what happens? My gas is going to leak by these cups, and I have a straight shot into the dip tube of this tool. There's like it varies maybe 3 to 6 inches to this point, okay? The shroud is our last piece or last key factor to consider when it comes to the Max. The shroud is also the biggest part of our patent around this tool. And it serves a very simple but very important purpose. He's protecting me from any gas that happens to leak by these packers or any other packer. And now, if I'm a gas bubble, I'm rising, and it's a very difficult decision for me to make the U-turn. Not only make the U-turn, but then drop an additional 12 inches to enter my 3/4 inch dip tube, and now I have a straight shot to the pump. We have to do everything we can to eliminate that, and the shroud does that for us.